we're going to talk about area. Now, hopefully, if you have been following my videos, you should see very, very quickly that a lot of the things we're going to talk about when it comes to area are exactly the same as the things that we were doing with multiplication, because area is just multiplication visualized. All right. And we've already done visualizing of multiplication. We did counting by arrays, we did skip counting, we did lots of ways of understanding multiplication. So all of those same techniques and thought processes that help us figure out multiplication will also help us figure out area. So let's start. Which shape has an area of 9 square units? So when you first learn about area, you learn about it in terms of here is 1 unit. Now, how many of them fit inside this shape? Obviously, it's going to get more complicated later when you have shapes that don't line up nice and neat. But for now, this looks like it is 9 square units all sort of put together. This one is clearly not, because they're not all the same size. This one's not, because they're not all the same size. But oh, how about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9. This also, even though it's a completely different shape, has an area of 9 squares. And it does indeed say choose 2 answers. Which shapes have an area of 8 square units? I don't know what the hell's going on with A here. But this is 1, 2, 3, 4, 5, 6, 7, 8. So you see, we're just counting again. And just like with addition and multiplication, we start with counting, then we start using counting to add, and then we start multiplying, using repeated addition to multiply. It's the same pattern that we followed, we're just applying it to shapes instead of numbers. 1, 7, 8. And I don't know what's going on with D. 15 square units. Now, we've already done counting by arrays. Students who have been, working through this curriculum from beginning until now should be able to figure out that this is 15 pretty fast. And in fact, this is exactly one of the models that we used to model multiplication. We used arrays of things in rows. And then we also said that you can flop it over, 1, 2, 3, 4, 5, and 3. And again, count it if you don't believe me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Which shapes have an area of 4 square units? That would be that one. And that one. So when it comes to area, the arrangement doesn't matter, but when we are counting units, we want to make sure that we are counting the same unit over and over again. In B and C, the units are different sizes, which means they're not units at all. That's understand area.